Now that we know how topic-specific PageRank work, let's see how we can apply this to measure proximity in graphs. And this is related to topic-specific PageRank when the title set S is a single element. And sometimes it's also called random walk with restarts. And let's say that we want to measure the proximity or relevance or closeness, similarity between node A and B in some graph. So what would be a good proximity measure? One idea is that we can use the shortest path between two nodes. But this is actually not a very good idea. Let me tell you why. Let's say that we have these three graphs, graph 1, 2, 3, and we want to measure the proximity between node A and B in these graphs. And apparently the proximity between A and B in this second graph should be lower than the above, than the first graph, because A and B in this graph is actually, its proximity is no difference from the proximity between A and E or proximity between A and F or A and G, right? So the proximity between A and B is not that, it's not that outstanding. So it should be lower than the proximity in the first graph. And on the contrary, the proximity between node A and B in the third graph should be higher than the first graph, because this node A and B, they're actually more connected because there are two paths between node A and node B. So basically, the shortest path is not a good idea, because if you look at these, the shortest path in this three graph, the shortest path, they're all equal to 2. And this is because it has no effect on the other nodes, E, F, and G. Another idea is that how about we use network flow? Because network flow will certainly consider other nodes. But as we can see in this example, if we look at the first graph and the second graph, we can see that intuitively, in the first graph, node A and node B should have higher proximity. But in terms of network flow, they're actually the same. Both graphs have a flow of 1. And the problem with network flow is it does not punish long paths. So what would be a good notion of proximity? A good notion of proximity needs to be aware of multiple connections. Let's say that if we have more connections between node A and node B, the calculated or the computed proximity must be higher, and also needs to be aware of the quality of the connection. And by quality, we mean whether or not these connections are direct or indirect, or even we need to consider the length, degree, and the weight of the edges. And one good idea is what we call Simrank. And what Simrank does is basically a random walk from a fixed node on the graph. So basically, we'll just perform a topic-specific PageRank from some node U with a teleport set. So basically, it originally will start with U, but the teleport set is also considering a single node U. Therefore, it will restart. It will repeatedly restart from U. And doing this, the resulting score would be a very good measure of similarity to node U. And the intuition is that if we rank all the nodes based on topic U, then the nodes that are ranked higher should be more similar to U. But one problem, of course, is that this must be done once for every node U. For example, if you wanna compute the Simrank for node A1, you need to run the PageRank algorithm a full pass. Basically, you need to go through multiple iterations. But if you want to compute the Simrank for node A2, you need to perform the algorithm all over again. So this is very computationally inefficient. Therefore, they only suited for sub web scale applications. When it's a full web scale application, it's actually computationally inhibited. Now let's take a look at an example to see how Simrank works. Let's say that we have this bipartite graph, and in this graph, we have two kinds of node. On the left, we have each node representing one conference, at each KDD, ICDM, etc., etc. And on the right, we have some authors. And a conference is linked to an author when an author has published in this conference. So based on this graph, we asked the question, what is the most related conference to ICDM? ICDM here, concretely, it's the International Conference on Data Mining. So our answer is that we need to run a topic-specific PageRank with a teleport set to include only one node, which is ICDM. And this is the result. If we run the topic-specific PageRank algorithm with one teleport set of ICDM, we get the following answers. And this is actually a very intuitive result. The closest conference to ICDM is KDD, which is a top conference in data mining. And the second closest is SDM, which is also a data mining conference. And next will be the PKDD. This is kind of the European version. And we have the PAKDD, which is the Pacific version. And we have the ICML, International Conference on Machine Learning. This is a machine learning conference. And it's related to data mining because they more or less use a very similar techniques. And we have the ICDE and Sigma, which are database conferences. And to briefly summarize, until now, we have talked about several versions of the PageRank algorithm. We talked about the normal or standard PageRank, which teleports uniformly at random to any node. And we have also talked about some extensions of PageRank, and one of them is the topic-specific PageRank, and this is also known as the personalized PageRank, and it teleports to a topic-specific set of pages. And we also talk about random walk with restarts, and this is the Simrank that we just introduced. And this is no more than just a topic-specific PageRank where the teleport set is always one single node, and it's always gonna be teleported to the same node.